Hi, today I'm going to introduce a automatic plant watering system using a Raspberry Pi. This system aims to address problems associated with plant watering, such as overwatering and underwatering. This solution provides a cost-effective and customizable solution to individual users. And now we can see two photos from this slide, and one is for underwatering and one is for overwatering. So it's quite important to properly water in plants in health and growth, since it ensures the abundant delivery of nutrition and oxygen to the plant's roots. That's why I want to build this system as my final project. Next, this is a traditional business watering system. So for the traditional commercial system, it's have their advantages and disadvantages. This the fact that they can be effective in some situations. They may not always be suitable for individuals users, since the cost because of cost complexity and a lack of adaptability to specific plant types and the environment conditions. After that, we go into the system components. In my system, I use Raspberry Pi, soil moisture sensor, water pump, and an analog to digital converter. These are four photos for my equipment of the system. The first is the Raspberry Pi, and the second is moisture sensor. After that, we have the water pump and the ADC for analog sign conversion. For this system, we connect the soil moisture sensor to Raspberry Pi using an ADC, and the GPIO pins allows for continuous monitor of soil moisture level. Now it's the flow chart of my system. The Raspberry Pi serves as the central part, while the soil moisture sensor is to measure the soil moisture level, and the water pump delivers water when needed. Next, this is the flow chart of my system. So when the user needs to water the plants, the program is to send the instruction if the soil moisture below the threshold. If yes, the system will activate the water pump. After that, it will send the instruction to check if the soil moisture reaches the deserved level. If it's yes, we just deactivate the water pump. If it says no, we just go to continue water the plant. And if the soil moisture is not below the threshold, we just wait for a set time interval until the time that until the time we set to water the plants. So for the water pump and the relay control, the water pump is controlled by relay module connected to the Raspberry Pi. When the soil moisture falls below the threshold, the relay is activated, and the water pump supplies water to the plants. Once the deserved moisture level is reached, the relay is deactivated and turn off the water pump, which is I talked for the flowchart of the system. So for the advantages compared with existing solutions, my Raspberry Pi based automatic plant, my Raspberry Pi using a automatic plant watering system offers several advantages. First, it provides real-time monitor of soil moisture, which allows for more precise watering to needs of the individual plants. Secondly, it's highly customizable and can be adapted to all kinds of plants and environment conditions. Additionally, with the Raspberry Pi, we can integrate advanced features such as scheduling watering times based on weather data of the local city. After that, we go into the ideal watering times. As we all know, watering during sunny days can be harmful for plants, even when the soil moisture level is low. To address this problem, my system can be programmed to water plants during specific time of the day, such as 6 a.m. and 6 p.m. of the day. Also, by incorporating a real-time clock and the sunset data, we can schedule the watering process during ideal periods to prevent potential harm to the plants. In the conclusion, my automatic plant watering system using a Raspberry Pi offers a great solutions to plants watering methods. By monitoring soil moisture in real time and adapting to different plant types and conditions, the system promotes healthy plant growth while saving water, energy, and time. Thank you for your time.